All right, thank you for joining me today. I'm going to be talking to you about positive and negative numbers on a number line and representing them in real life situations. All right, so first of all, let's take a look at some terms that you'll need to be familiar with. First of all, what is a positive number? Well, these are the values you've been dealing with throughout math, your whole school career. These are the numbers that are greater than 0 on the number line. Or if you're looking at the number line, they're the numbers to the right, okay, like you see down there at the bottom. Also, negative numbers. If you're not quite familiar with negative numbers, they are actually the opposite side of the number line. In other words, 0 in this case is what separates the positive numbers and the negative numbers on the number line. So your negative numbers are any number less than 0 or to the left of 0 on the number line. We also have this term integer. An integer is simply a negative and a positive whole number. Okay, and a whole number, if you don't remember what that is, a whole number is your counting numbers. I like to refer to them as your like Sesame Street numbers, 1, 2, 3, 4. Okay, so an integer is simply the negative version or the positive version of that. So for instance, 1 and -1, or 2 and -2. Finally, opposites. Basically, opposites are what I just wrote there a moment ago. They're simply numbers that have the same distance from 0 on the number line. So if you look down at the bottom at our number line, you can see we have -1 and 1, which would be opposites. Then you also have 2 and -2, which would be opposites. And just above my work there, you can see a couple more examples, 3 and -3, 10 and -10. All right, so let's take a look at what they're going to be asking you to do here. First of all, identifying opposites. They'll want you to take and identify the opposite, in this case of 12, on a number line or any other number on a number line. So let's draw out a number line real quick here. Okay, of course we have 0 in the middle. I'm going to notch out 12 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here's our 12. All right, now to do the opposite means to just do the same thing, but to the left. So we're going to do 12 places, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. That would be your -12. Okay, so that would be identifying the opposite, would simply mean to mark that on your number line. So -12 would be our opposite of +12. Right, let's do one more here. Locate 1/2. Now again, I realize this isn't a whole number, it's a fraction, but even fractions and decimals have opposites. And again, if you haven't been able to recognize it yet, what makes a number an opposite mathematically is simply putting a negative sign in front of it or taking it away if it already has one. So in this case, locating it on the number line, let's draw that out real quick. We'll start by marking 1/2. So here's 0 and here's 1. To mark 1/2, we're just going to split it in half. That's where 1/2 would be, and that's basically what that number refers to, is splitting it in half. So here's 1/2. So again, we're going to do the exact same thing to the left of 0. We have our -1. All right, or excuse me, I'm giving myself a little bit more room there. There we go. Now we have -1. There we go. And then splitting it in half, we would have our -1/2. So to show that, we'll place a point directly on the number line to show that we've located it on the number line. All right. Next example here is finding what we call the opposite of the opposite. Okay, and this basically is a two-way thing. It's basically a two-step problem. They want you to identify the opposite of 8 first, and then the opposite of what you get there. So I'm going to show it to you on a number line real quick, and then I'll just give you the shortcut. You'll probably figure it out though. All right, so if we draw out our number line and we have 0 in the middle, notch out 8 places, 1, 2, 3, 4, 5, 6, 7, 8. There's where 8 would be located. Then we do the exact opposite, 1, 2, 3, 4, 5, 6, 7, 8. There's where -8 would be. Okay, normally we would just have you mark the opposite, but notice they want the opposite of the opposite. So what I'm going to do is show you how that works. First of all, we're marking -8 because that's the opposite of 8. All right, but because we have to do it twice, we have to find now the opposite of -8, which would then, of course, take us directly back to where we began. So your answer to this problem is actually 8. So if you haven't figured out the trick to that, if they want you to find the opposite of the opposite of a number, that really just means they want that exact same number. So for instance, the opposite of 8 would always just be 8. Or the opposite of -2 would be -2. It doesn't matter if it's negative or positive, okay? So let's look at one more. What is the opposite of -2? Well, I just didn't mean to, but I just gave you the answer to that one, okay? But let's look at it real quick on a number line just to show you one more time. All right, you have 0 in the middle. We'll go ahead and mark out 1 and 2. And then over here you would have -1 and -2. All right, so again, the opposite, first of all, we'll mark -2, which would be here. They want the opposite of that, which would be here. But then they want the opposite again, which brings you right back to where you began. So the opposite of the opposite. It's like going in a whole complete circle, right back to where you began. So your answer to this problem would be simply -2. So in real life context, what they're going to do is give you problems such as this. Write an integer for the following situation. And what you need to do here is look for common terms like below or above, things that refer to going up or down. Okay, and you'll see a lot of those terms referenced, and I'll point them out to you. Our first example here would be 32 feet above sea level. Okay, the term above. When we think of above, hopefully you're thinking up or rising, okay? 32 feet above sea level would be what we consider to be a positive value, because anything going up is going to be considered positive, anything going down is going to be considered negative. So 32 feet above sea level, to represent that as an integer, you would simply just write 32. No tricks to this. It's just simply recognizing whether it should be a positive movement or a negative. So above means up, which always should reference positive. Going down 6 floors, again, your key term there is going to be down. Okay, if up is positive, then down must be negative. So if we were asking you to write this as an integer, you're going to need to put a negative sign in front of it, because going down means you're going in a negative manner. Going down is negative. Going left sometimes can be considered negative. Think about the number line. Going right and up typically are both positives. All right, a couple more here. Write an integer for the following situations. Okay, a football team loses 25 yards. So again, notice the key term here would be losing. Would we consider that positive or negative? Well, again, in the case of playing sports, we would look at that as being a negative movement or just a negative occurrence. And that's the correct assumption in this case, because it is a negative value. You're moving backwards from the direction that you want to go. So that would be -25. Gaining 12 pounds. Well, again, the word gain means to go up, okay, or that you have a movement trending up. So gaining 12 pounds as an integer would be represented with a +12. Now, you don't necessarily have to put the positive sign. You've noticed I haven't been doing that. That's not necessary, but it is something you will see from time to time. So I don't want you to get thrown off by that. All right, this has been a quick tutorial on representing integers on a number line.